All right. So, hello and welcome everyone. We are live right now. Welcome back. Welcome back to this amazing platform of Tutee Learning. Today, we will be discussing about the second lecture of three-dimensional geometry, right? So, as of the last class, we have been discussing with some of the important topics regarding the three-dimensional geometry, starting with the very basics to understanding of the direction ratios and direction cosines, right? So this is what we have discussed in our previous class, right? So I hope this particular discussion is clear to all of you. All right. So once we understand on how to represent any generic point in a three-dimensional space using the direction cosines and direction ratios, then we can solve or understand any types of formulation that will come up in our three-dimensional geometry. So today we'll be basically discussing about on the same formula, but before that let me also introduce you to some other important concepts regarding the triangle and the volume of the tetrahedron, right? Now we have already discussed about this particular thing about finding out the area of the triangle, right? So if I have, let us say, I give you a triangle, if I give you a triangle in the three-dimensional space, let us say the coordinates are given as follows. All right. So let us say the coordinates of the points of the triangle are given as follows. Now we've already seen that by using the vector relations we can find out the result for the area of this triangle, right? So the result is very simple. What we will do is that we first try to form two vectors, right? And then area of this triangle ABC can be given as half times of the mod of, let us say we take BA vector cross BC vector. So if we find out the magnitude of these two vector cross product, BA vector cross BC vector, then we can simply find out that what is going to be the area of this particular triangle, right? Now there is one more way to understand this area of the triangle in the three-dimensional geometry. So that I'm going to discuss today. Let us say that if you try to imagine this particular thing in three-dimensional geometry, we can get this same answer by considering one of the axes, by considering is a 2D case, right? What I mean to say is that let us say that I consider this similar triangle and I compress it or take a projection. So let us say this is my three-dimensional triangle. This is my three-dimensional triangle on the 3D axis. So let us say this is X, this is Y, and let us say this is my Z. So it is difficult to explain this particular thing in 3D, but I will try my best. And I request all of you viewers to imagine this particular situation as I keep on explaining. So let us say this is my point A, this is my point B, and this is my point C, which is basically present somewhere in the 3D space. Now, what I'm trying to say is that you try to project this particular area on these three 2D planes. What I'm trying to say is that if you project this particular area, on the XZ plane, if you try to project this area on this XZ plane, then you will also obtain a triangle, but the area of the triangle will be different. Let us call that particular area of the triangle as delta 3. Similarly, you project this particular thing on this particular plane. So something like this. So you project this particular triangle on this YZ plane and we get another triangle, and let us call this particular area as delta 2. In a similar manner, if I project this on the XY plane, then I will obtain another triangle whose area, let us say, that is delta 1. right? Now what do I actually mean by when I doing the projection is that, so let us say this is a point x a which is given as x1 y1 z1. So when I try to project this point on my x and y axis, this particular point, let us say a dash, actually becomes x1 y1 comma 1. Okay, so we are trying to form such point where, sorry, comma 0, right, comma 0. So we are trying to form this particular a dash such that it is lying on the xy axis and it is kind of a 2D triangle. Now you already seen that how to find out the area of this 2D triangle is that you can find out delta 1 simply by doing half times the determinant of x1 y1 0, or sorry, x1 y1 1 and x2 y2 1 and x3 y3 1. So if you take the determinant value of this, you will obtain lambda 1. Then delta 1, right? So in the similar manner, you obtain delta 2 as well as delta 3. Now once you obtain this particular delta 1, delta 2 and delta 3, these are the results or the value of the area of the triangle in the 2D plane. So these are the values of the triangle in the two-dimensional plane. So what I obtained as delta 1, delta 2 and delta 3 are nothing but the area of the 2D triangle. However, I need the area of this three-dimensional triangle, right? So in order to find that, this can also obtain this, let us say that three-dimensional triangle, the area or the actual area is delta. So this delta can be actually obtained as, so the delta can be given as by the relation as square root of delta 1 squared plus delta 2 squared plus delta 3 squared. So these are very similar, very generic relation that you can also use to find out the area of the triangle in three-dimensional plane. Now my sole purpose to show you this particular calculation is not to show you that you have to do this kind of effort to get out to the answer, right? The simple way to obtain the area of the triangle in the 3D case will be just to perform this particular vector result. Is just to perform this particular vector result, which is very simple and easy to do. However, learning this kind of methods will actually help you to understand that there is a concept where we can project the 3D thing into a 2D thing and then we can carry out the algebra. So that is my sole purpose of explaining you this particular relation. I hope this is clear to all of you. I hope this result is clear to all of you. Okay, so this is the only sole purpose that I wanted to discuss about this particular thing. Alright, so please keep this particular part in mind so that whenever we can apply this particular concept in our future things as well, right? Sometimes it is not always feasible to find out the vector product, right? So maybe this kinds of thing would actually help you. Let us say the question is given you that there are three projected triangles on the three planes, xy, xz and yz plane, and then they are basically combined to form a 3D figure. Try to find out the area for that or try to find the volume for that. So in that particular questions where you have to do the reverse engineering kind of thing, in those kind of problems, this particular idea is going to help you a lot. So please take a note of this particular formula and so that we can apply this in our upcoming discussion. Alright. Also along with this particular result, now I want to also discuss about another result that is related to tetrahedron. So I want to discuss about another result related to tetrahedron. So the tetrahedron thing. So if I say that the tetrahedron is formed by, and we have already seen that tetrahedron is basically a 3D figure, right? So if I need to find out the volume of the tetrahedron such that the base of the tetrahedron is given out by the point x1, y1, z1, the point B is given as x2, y2 and z2, and the point C is given as x3, y3 and z3, right? So if we have, and also the point D is given as x4, y4 and z4. Now we have already seen that in order to find out the volume of this tetrahedron, ABCD, in order to find out this volume of this tetrahedron ABCD, we can obtain this by doing the 1/6 and by taking this following three vectors. So if I call these vectors as A vector, B vector and C vector, the result is 1/6 times the scalar to your product of these three vectors, right? Now this is what we've already studied in our earlier discussion of scalar to your product, right? However, if I need to find out this volume by using this particular coordinate points, I know that when we are solving for this scalar product, we actually have to find or use the coordinate to take out the value of the vectors, right? However, if you want to do it in a faster approach, you can find out the similar volume, the same volume as taking as 1/6 time the determinant of this 4 cross 4 matrix, and that is x1 y1 z1 1 x2 y2 z2 1 and similarly x3 y3 z3 1 and x4 y4 z4 1. So if we find out the determinant of this 4 cross 4 matrix, we also obtain the similar volume. Now if you know or you have studied about determinants, then by using the properties of determinant, we can also get back to this particular result as well. So these are basically the similar results. Okay, just I am trying to extrapolate the result in terms of all the coordinates. I hope these two results are clear to all of you, right? So once these particular results are clear, now we are in a better position to start the discussion of this actual chapter. That is, we're going to start with today's discussion on. So from today onwards, we are going to start with our important topic or the most important part of this lecture, that is going to be the straight lines. So now from today onwards, we're going to discuss about the straight lines in planes or in three-dimensional geometry, and we're going to start with discussing about the planes in the upcoming lectures. So from today onwards, we are starting our discussion with the straight lines in 3D. So let's try to discuss about the straight lines in 3D. I hope this is clear to all of you. Alright, so I hope this part is clear. So now we can move forward to discuss about the concept of straight line in space. So straight line in space. Now we have already studied a chapter of straight lines that was basically a 2D straight line, right? However, in this particular part, we're going to study about straight line in a 3D space. So we are first of all going to understand how we can come up with the equation for such straight lines in three-dimensional geometry. So for that, let's try to understand the same situation. Okay, so let us say that I have a three-dimensional axis, the x, y and z axis, and let us say I have any straight line in this 3D plane, something like this, which is going from point A to point B. Now I don't know the end point because it is a straight line, so it will have a fixed starting point. However, it does not have a fixed end point, so I will show with an arrow. Now if you recall that, let us say the point that is the initial point is the fixed point, and I know the coordinate for the fixed point, as x1, y1 and z1. And let us say I take up any general point on this particular line, and let us call that by position vector r, and this is by position vector small a. So let us call this a general point. So this is any general point. Okay, so this is any general point on the line, and I can give that particular point by some coordinate x, y, z, because it is a general point or a variable point, right? Now I say that also along with the initial fixed point, I say that the line is directed towards the direction ratios of this line is given as L, M, N. So the direction ratio of this particular line is also given to us. Let us not write L, N because that will denote the direction cosine. Anyways, you can write that part. However, okay, let me write that as L comma n, which are the direction ratio cosines. Okay, so let me call this as the direction cosines. Okay, so these are my direction cosines. So direction cosines are given as L, M and N, which is already known to me because I will know that for a straight line we will be directed towards some particular angle or direction, right? So I will know the direction by the direction cosines. And I know that what is my initial or fixed point. Now once I have this particular idea, now from here I can use this particular concept to generate the equation of this straight line in space. So in order to discuss about the equation of the straight line in space, I can go about by two formulation. One is the Cartesian form and another is the vector form, which are related to each other. Let us first of all discuss about the vector form, right? So what is my motto is to derive the equation of this line, is to derive the equation of this particular straight line. Is to derive the equation of this particular straight line in the 3D space. Alright, so let us see how we can go about do this particular straight line in 3-dimensional space. Now I have already, so let me first discuss about the vector form. Okay, so if I start to discuss about the vector form or how by using these vectors we can obtain the equation of the straight lines. Now what you have seen that whenever we produce some equation, we try to incorporate the unknown thing with the known quantity, right? So we try to relate the independent variable to the dependent variable. So if you look in this particular case, what I have discussed, we are saying that this A point, this particular A point is my fixed point, and I know that this A point is corresponding to the position vector that is given by small a vector. Also, I know, and let us also say that the position vectors or the direction ratio vector is given by a b vector, or the direction of this particular line is given by the b vector. In that case, what I can form, and r vector is my general vector or the variable point. So what I can do is that I can write the equation of this particular vector by using the parallel concept. So this particular line is directed towards, let L vector, we have assumed that with b vector, that the direction of this line is directed towards b vector. And we can also produce another vector by using the general point, that is r vector minus a vector will give me the vector which is directed about the line, and that will be equals to some lambda times this b vector, some lambda times the b vector, where lambda is my constant, right? So from here I can form my unknown, that is r vector, to be known vector a vector plus lambda times of b vector. So what we know is that we know a vector, we know b vector, and lambda is the variable parameter which can be varied to obtain different r's. So therefore this will form a general equation of straight lines in space in form of a vector equation. So this particular way of writing the form of equation denotes the vector equation of straight line in space. Is this particular clear? अजय राज भैया स्टडी रिलेटेड हेल्प कर सकते हो क्या आप? जी बिल्कुल अजय राज, yes, I do help people for this particular thing, okay, but try to understand and tell me your doubts. If you're having any question, I will try to repeat it again. Okay, please tell me your doubt, Ajay Rai. Do you have any question then? Okay, so this is how we actually obtain the equation of straight line in space in form of vector equation. Now from this vector equation, we can get back to the Cartesian form. That is, so if I have to discuss about the Cartesian form, which I can write it as the Cartesian form would be given as, so r vector minus a vector can be written in terms of the vectors, where I can write r x minus x1 vector. This particular is a component of the vector directed along the line, is the vector which is directed along the line, right? Which is directed along the line, and this will be also equals to lambda times the component of the b vector, which can be lambda times the li cap plus m j cap plus n k cap, right? Because this is my direction cosine, and multiplied with a constant will give me the particular vector along which it is directed. Or maybe I can use the direction ratios also over here, right? So this can be commented as, because these two lines are parallel, because these two vectors, I should not write equal, I should write these two vectors are parallel. Alright, so these two vectors are parallel vector. So these two vectors are parallel vector. Therefore, the individual component, that is, would be constant. That is, x minus x1 by L is equals to y minus y1 by m is equals to z minus z1 by n. This is how we will obtain the result for the Cartesian form of the straight lines. Alright, so this would be a constant, and that particular constant is given as lambda. Alright, so this is what can also be used to obtain the equation of straight lines in Cartesian coordinate or Cartesian form. Is this part clear to all of you? So these are the two forms of writing the equation of straight line in space. Is this part clear to all of you? Is this part clear? Now this is the form of the straight line equation when I know one fixed point or the initial point, and I know the direction of the vector along which the line is directed. However, if I don't know the vector along which the line is oriented, however, I know any 2 points on the straight line, then also I can obtain the equation of the straight line in the following manner. Let us say that I know in a straight line, I know my 2 points which are lying on the straight line. Let us say the coordinate is x1, y1, z1, and the b coordinate is x2, y2, and z2. I know these are the 2 points which are given to me, right? However, from this particular thing, if we need to write the equation of the straight line, I can do again the similar result. That is, I can assume another general vector or general point as x, y, z, and then I will try to produce one vector like this, and the a vector would be given as the direction vector or the direction along which the line is directed, which is basically from our previous discussion of the nomenclature, it is the b vector. So what I can do is that I can write r minus a vector to be some lambda times of b vector, and this b vector is nothing but my ab vector, right? So from this result I can easily obtain my equation of the line whose 2 points I know, and that will be lambda times of b vector minus a vector. Well, let us say the position vector of point B is small b vector, and the position vector of A is given as small a vector. So if I write like this, then I will write over here as b vector minus a vector. So this is going to be lambda times of b vector minus a vector. So from this formulation, we can also find out the equation of the particular line where I know the 2 points that is lying on this particular line. Similarly, in the Cartesian form, I can write the same thing as x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1 is some lambda. Okay, so this is how I can obtain the equation of the straight line in a Cartesian form, in my Cartesian form. I hope this is clear to all of you. Alright. This is how I can find out the equation of the straight lines of the following forms. Is this part clear to all of you? Is this part clear? This concept is going to be very straightforward, right? Very simple and very straightforward. So please understand the concept so that we can use this particular ideas while we start to discuss about the questions. Okay. Also, from here, if I tell you that I need to find out the angle between the straight lines or the 2D angle between the straight lines in 3-dimensional space. So in a similar manner, if I give you two lines, let us say this is my line number 1 and this is my line number 2. If I need to find out the angle between the line that is given as theta, I can also find out this theta by finding out the angle between these two vectors which are directed along the line. So if I know the direction ratios of this line, let us say the direction ratio of the first line is given as L1 vector, and the direction of the second line is given as L2 vector. So if I know the direction ratios, this is my direction ratio vector. Okay, so if I know the direction ratio of my straight line, then by using the angle between the two vector concept, I can simply find this theta. So this theta would come out as L1 dot L2 vector divided by mod of L1 into mod of L2. So by using this particular concept, we can find out the angle between two straight lines in space. Is this part clear to all of you? Is this part clear? Alright, so let's try to use this particular idea to solve some questions. Okay. So let us say, as the question mentions, so we have certain questions. Let us try to give you the question. So it's a simple MCQ questions. Okay. So let's try to solve some question to get an understanding of whatever we studied. So this is my first problem. So let us say we have given with the two equations of the lines in space, and there it is said in the problem that these lines are perpendicular to each other. So if these lines are perpendicular to each other, I need to find out that what is this value of k, right? So it's a very straightforward and a simple problem. So what you have to do is that you have to first of all find out the direction ratio vectors of these two straight lines. So once you get the direction ratio vectors of these two straight lines, from there, by using the concept of angle between two vectors, you can find out that what will be the angle. And it's mentioned in the problem, it is at 90 degree. Therefore, the dot product of those two vectors will be equals to 0. So use that particular concept to find out the value of this unknown k. So please try to solve this problem. Please try to solve this problem. This is a very basic and a simple problem to start with. So please try to solve this problem. Alright, so let's see how we can solve this problem. So from the following equation of the line, we can obtain the direction ratio vector of these two lines as follows: minus 3 I cap plus 2k cap plus 2 times 2k times j cap plus 2k cap. Similarly, my direction ratio vector for line 2 will be given as 3k times I cap plus j cap minus 5k cap. And it is said that these two lines are perpendicular to each other. These two lines are perpendicular to each other. Therefore, I'll simply apply the concept of dot product to be equal to 0. So if I just make the dot product to be equals to 0, then I can obtain the value of this unknown, that is k. So let me draw that part out here. So it is going to be minus 9k plus 2 minus 10 will be equal to 0. So from here, I can obtain my value of the k as equals to minus 8 upon, oh sorry, let me check the solution again. So, okay, there is a 2k missing over here, right? Correct. So yes, so now from here, if I solve it, I'll get the value of k as minus 10 upon 7. So the value of k would be obtained as minus 10 upon 7. So from this, the correct answer to this particular problem is going to be option number C. Very simple, straightforward question to start with. Let us now discuss about another set of problem. Let us say we have given the lines as follows. So again, this question is given where the lines are given as follows, and it is said that they are perpendicular to each other. Alright, so in this case also, you have to first of all obtain the direction ratios of the corresponding line vector. How can I do that? Now this question is a bit tricky in terms that it is not directly giving you the result. It is said that the line is given as x equals to ay plus b and z is equal to cy plus d, and another line is given as x equals to a dash y plus b dash and z is equal to c dash plus d dash, c dash y plus d dash, right? That is what is given. So from here, first of all, you have to obtain the equation of the straight line. That is going to be the only crack in this question. How can I do it? What we can observe is that in these two equations, one equation and second equation, I have y which is common in both the equation. What I can do is that from this particular relation, if I write x minus b upon a will be equal to y, and this also equals to z minus d upon c. So what I can do, I can write this y as y minus 0 upon 0. Right. Now this is a very interesting concept that division by 0 is not something possible. However, we are not writing division by 0. We are trying to refer to that the ratios are a constant value. So in order to represent that, or in order to take that and say that the contribution of the direction ratio in the jth direction for the direction ratio line or the line vector is 0. That's the simple way to write or explain this idea. So from here, I will find out my direction ratio vector along the line 1 as ai cap plus ck cap. Alright, this is a very important idea to understand. Similarly, my L2 vector will be obtained as a dash I cap plus d dash k cap. Oh, sorry, c dash k cap, right? Correct. C dash k cap. This is how I will obtain the two lines or the vectors of these two lines which are denoting the direction of the line. Now from this part, I can conclude that since L1 is perpendicular to L2 vector, therefore my dot product of these two line vectors should be equal to 0. Right? So from here, I can obtain this simple relation, that is AA dash plus CCC dash CC dash should be equals to 0. Now this will generate the result of the following answer. Alright, very simple, straightforward. So the answer to this question is going to be, oh, very sorry, just a short mistake. Whenever I am not denoting the direction along this particular thing, so it is not exactly 0, it is y minus 0 by 1. Okay, so I can also write this y as y upon 1. That is what I'm trying to do over here. Similarly, so there will be a j cap component. Okay, a very big mistake that I have committed over here, so please don't make this kind of silly mistake. Okay, so the correction would be, there is a component of j cap like this. So therefore, from this particular result, you will obtain this particular value to be minus of 1. Okay, a very important correction. Alright, so over here, whenever you are writing like x minus b upon a is equals to y upon 1, right? So we can write this part as y, something like this, right? So therefore, we have to write like y upon 1. Now if you write it 0, then the contribution on the j direction is getting lost, right? So that is not correct. Okay, so whatever I explained earlier was wrong actually. So I thought that we could not take the direct component, right? However, what I missed out to understand is that there is a y component which I can write as y upon 1. Okay, however, we will see some questions where there will be 0 maintained over here. Okay, so that I will take up in our upcoming discussions. Okay, good afternoon. Alright, so this is going to be the basic foundation on understanding how we can change the Cartesian form of the vector equation from the vector form, or maybe how we can simplify the given equation in a simplified manner of Cartesian form, and from there how we can solve the questions. Okay, so this part would be more clear if I explain you the concept of reduction of Cartesian form of equation of line from vector form or to the vector form, right? So this particular transformation of the vector form of equation to the Cartesian form of equation, or the Cartesian form of equation to the vector form of equation, whenever we will discuss that particular part, it will be clear. For the time being, you can take up that whenever you have this kind of equation of line, you have to get the common ratio. So here my basic common thing was to make the y equate on both the side, and that's how I obtained this particular equation. Alright, so this is how I obtained my following equation, and from this I can use this result to solve the question. I hope this is clear to all of you. So with this part, I will conclude the session over here, and we will discuss about the upcoming discussion on intersection of lines as well as reduction of Cartesian form to vector form. Also, we'll discuss about the other concepts regarding the foot of perpendicular or mirror image of a point with respect to a line. So those all concepts we are going to take up definitely in our upcoming lectures. Also, we're going to explore the concept of shortest distance between two straight lines, or whenever two straight lines lie in a plane. Okay, so those all are the important concepts that we need to discuss as the upcoming lectures, and we'll see that there are a lot of questions that has been asked from those particular topic itself. So with this part, I thank you for your attention, and I hope to see you soon in our live discussion. So if you're new to this particular platform, please like, share and subscribe, and also hit the bell icon so that whenever we are live, you get a direct notification. And in the upcoming sessions, we are definitely going to start with one-shot lectures. भैया आप दिन में कितना बार? So we are definitely going to start with our one-shot lectures. Okay, so and in the upcoming lectures, we will be discussing with the JEE Mains question as well. Alright, so all those things are going to definitely come up on this particular platform. So please subscribe to the channel and hit the bell icon so that whenever we get live and we have this particular videos out, you can directly join us and you can study us directly from us. Okay, now it is not only for maths, it is going to be for chemistry and physics as well. So why wait? So please subscribe to the channel and also follow this particular contents and on daily basis. Okay, so please be consistent enough for your upcoming JEE Mains so that you can easily crack that particular examination. So with this, thank you, and I wish you all the best.